Okay, we're doing a lot of review that's going to help you for the test that's coming tomorrow. And I want you to pay attention to this, do your best to kind of practice all these log things that we have learned. At the very beginning, I posed this question to you, 5 to the x equals 10, and said that's kind of why we need logs. But it was sort of a lie, because you could have just graphed both sides and, how do you finish that? See where they cross. Yes, graph both sides and see where they cross. It is a classic technique that solves many questions. In fact, so many that we can't allow calculators on this test. Otherwise, you could probably just graph both sides and see where they cross on every single problem. So, you are going to instead be able to solve this algebraically by doing something with logs. Now, I'm moving this 10 over. What do you think I just made room for? A log. And I could do this by writing logs on both sides. And I could do this as just a rewrite. I would like you to do it both ways and see which way you think is more efficient. And by the way, if you're going to do a log on both sides, which base should you use? False. Log base 5 would be a logical choice, because then your x is instantly down out of the exponent spot. But log base 10 is a close second. So at least you had the second best option there. All right, try solving this both ways, both by putting a log on both sides and by doing it as a rewrite. You need to be able to do both because it depends on the situation, which one you'd want to use. I'll pause while you give that a try. Okay, enough with the riff-raff on their offers to do various math problems if I will do dance moves. No, it's not going to happen. All right, we have log base 5 of 10 equals x. That's actually the easy way. Look, x is alone, all in one swift maneuver. Option B was to put a log on both sides. If I do this, though, I've chosen what I would say is maybe the second best log I could have picked. Because if I put this log on both sides, I got a bunch of steps still. Because what base did I just put on both sides? 10. But if I put a log base 5 on both sides, I think it's kind of cool because this part just collapses down into just saying that the answer is x. So x equals all that is instantly solved again. All right, so that's one pattern. How about this one? E to the ln 5 power. What's the answer? Yes, sir? 5 is correct. And the y? Log base E, excellent. And then they both have a base of E. It's just their bases in different ways. And so therefore, the answer is 5. Okay, now extend that a little bit and see if you can handle this one. Thursday of this week. Been waiting. Oh. Solve. It's really not that hard once you find the green part. I'll pause for a second while you. This is E times ln E to the power of 1/2. There's all kinds of little steps you can take, and every time you take one and you go, oh, I see, that's really just this, you're going to get it simpler and simpler and simpler, and your answer for this is a nice, simple integer. In case you've forgotten, integers are not fractions. They can be positive or negative, and they're generally like counting numbers, except you also include 0. I'm going to pause for a second. Why don't you compare with the person to your left or right, as I normally pair you in here, and see if you get the same answer as they did. Here we go. I hope you notice that if it doesn't have a base, you should put a base, base 10, and then you go, oh, wait, those are the same. So this is just -2? Yeah, it's just -2. And then put the base, log base E, and if those are the same, then that's the answer, but I have the complication of that little piece right there. So let's put that e up there. That would work. And then I'd have all of this matches up, so the answer is that. Okay, so that is to the 1, okay, 1/2, -2 to the 1/2 e equals 2x. I'm close. Now I just got to get the x alone, and so I divide both sides by 2. 2, divide by 2, and this cancels, and this is a little ugly, but that's the answer the way I wrote it. I actually intended for this to not be 1/2. I misread my writing, and it should have been 1 over e. Now watch how clean that would have been. If this was 1 over e times e, what would that be? That'd be a 1, and then -2 to the 1 would be -2, and then -2 divided by 2 would be -1, and then your answer would have been x equals -1. But because I miscopied my original problem and had a 1/2 right there, it wouldn't all simplify down nicely, so you'd have to leave it that way as your final answer. All right. That's just checking some patterns to see if you recognize them. Let's talk about expanding and condensing. So here's the expanding problem. Log base 2 of x squared over 3y. Would you expand that as much as possible? Expand it. So if you're going to use base 2, you're going to want to stretch it out into a bunch of log base 2s. If you don't have at least 3 log base 2s, you're doing something wrong. I need an opinion from you guys. I know a number of you are athletes. And so, thank you for the recording. I think I'll pause the recording for this part because it's more of a individual question, doesn't have to do with the math. All right, so the next one here was an expand. So we're saying log base 2 of x squared. I know I'm not done yet. Plus, no, minus because it's a divide. Log base 2 of 3y. But I'm going to be smart and split it up right away. So plus log base 2 of y. Now, what's the one last thing I need to do? And yes, this part should be in parentheses. Do you get that if I don't have that in parentheses, only this part would be being subtracted? Okay, and then the last piece is the 2. The 2 needs to go down to front like that to truly expand it all the way. Raise your hand if you understood that. Okay, good. Next step is, if you get that they're expanded, then do you get that you can also contract them or condense them? Try this one. 5 log base 2 of 10 to the -3rd. Now let's just make it log. All right. Plus log of x is equal to 10. Solve. You're going to condense the left side, and you're going to simplify things as much as you can. And I'll give you a hint. I didn't write the base, but it might be handy for you if you did write the base. Correct. This is just a log, and that's the argument. And so I did not write the base. So therefore, what is the base? 10. And this one has a base 10 also. Yes, you should note that and use that to your advantage. Yes? Yes, there can be an exponent on your... This isn't a... No, this is the argument right here. So this and this are the same, so that's a big hint. And yeah, there's only one exponent here. It's that. Nope. It's just a -3. Okay, good. The answer will be ridiculously large. If you did not get a ridiculously large answer, then something went wrong. Simplify that left side. You got it already? Okay, cool. All right. Brooke, why don't you start this one?
First, I just did, since the is the same, I can just -3.
So this is just -3, and therefore that's -15 if we include that, and then. Yep, there's a 5 over there. All right, so we add 15 to both sides, so 10 plus 15 makes this 25, and now this is all gone. Good.
And then I rewrote it so it was
There you go, 10 to the 25th power. Okay. Next one. Have you guys heard of zebra mussels? Yes. They are becoming an issue in Lake Minnetonka. Like when I pulled out a weed the other day, and just to clarify, it was a milfoil weed, I was able to find about like 8 of these stupid zebra mussels stuck to this one piece of weed. And if that gives you any idea, are you going to laugh every time I say weed? I think you are. So I'll start calling it foliage. Anyway, when I found like 7 stuck to one piece of greenery, I was shocked and appalled at how many there must be in the lake. You know, unless I got the unlucky one. If there's that many, there must be literally tons of them in that lake, and there were none of them just a few years ago. That is what we call exponential growth, right? So let me give you an exponential growth type question. Do you know what equation you're going to be using right away? I'll give you a hint. It has an E in it. Go ahead. Yep.
It's like y equals y0. The growth one, so it's like a or something.
Yes, there you go. Good. Okay. Now, would you use that, please, for this situation? Imagine for a moment that you had taken the data and found that there was, in a typical cubic meter of lake, you were able to find 2 zebra mussels per cubic meter, like a 3-dimensional thing. 2 in a cubic meter. Then imagine for a moment that it went to 9 per cubic meter over the course of 7 weeks. That's exponential growth. My question is, what would be the equation that you could write? By the way, it's pretty much the same equation, except you'll know what K is. What would be the equation that you could write that would give you how many zebra mussels are in the lake at any given time? That's it per square meter of lake, that is. No calcs. Expect to not have calculators available. You're going to have an answer that I'll say like ln5, that kind of thing. I don't expect you to know what ln5 is in your head. I'll pause for a moment while I give that a shot. You are going to solve for K, but my question was not tell me what K is. My question was tell me what the equation will be that will give you the amount of zebra mussels at any given time. And so basically it's the same equation, except you'll know K, and so you plug the K in. Yes, question? At time 0, that was our starting time, there was 2 zebra mussels. That's when we first noticed that there was an infestation, so to speak. I'll pause while you give that a shot. Okay. Did you start by making a little table? That's what I think you should have done. Where this is time, and this is the amount. Times 0, we got 2. Times 7, we have 9. Get it? All right, next. I'm going to start with y0 being my original amount, which is 2. My new amount is 9. My k, I don't know. My t was how big? 7 times 7. So then I write 9 equals 2e to the k, 7. And last hour I was having somebody rewrite this and they just rewrote it the way it is. Will that work? No, you have to get the clump alone. So this is the clump. How do I get it alone? Divide by 2. And then I have log base e, because that's the base, of 9 halves is equal to 7k. And I divide both sides by 7 or multiply by 1/7. And there you have it. Raise your hand if you calculated k correctly. Good. And if you, I will leave it up there for a second. If you were to stop right there, though, sadly, that would be wrong. Because remember, I asked for an equation. That's not an equation. That's a k equals. I guess it's an equation. But an equation that would calculate for me the amount of zebra mussels at any given time. That goes back to this equation. So basically, I got to rewrite that equation, except make k be this. So I'm going to fill it in around this. It'd be y is equal to y0 e to the power of all that, which is k, right, times t. And then if you gave me a t, I could figure out what my original amount was. Again, if I knew my starting amount, since I do, actually, I should really do that. I didn't think about that. I know my original amount. Shouldn't I just put in a 2 for that? Yeah, I think I should. I think I did that wrong last hour. Because am I ever gonna have a different original amount? Well, so I should put 2 in there. There we go. Now it's just got 2 variables: y, which is how many zebra mussels you'll have, and t, which is time. Yes. Yes, you can move it up there if you want to. It'll end up being the right answer. And yes, you could leave the whole thing over 7. Instead of this 1/7 here, you could have this whole thing divide by 7. That is an okay thought. And I should put parentheses around the whole thing then and times it by t. Yes? I'll pause for a second. Okay. So let's do another one. Yes, sir. Question about this one. Yes, it is true the equation can be done with y0 being different things. But the easiest way is to just leave it as y0 is 2 because we started at 2. And then our time is just t. If we do a different thing, if we were to move it and like say, I want mine to start at like 6, you could actually do that. But then you would have to adjust your time every time. This t would have to be much more complicated. So bottom line is, it can be done that other way, but this is probably the easy way to do it. All right, that was a compound growth kind of equation. Now let's talk about inverses. Y equals 5 to the 4x. If you can sketch that, you'd probably be able to tell me its domain and range pretty easy. Why don't you start with that? Then why don't you try to build its inverse and tell me its domain and range? Logs and exponentials are inverses, right? This is an exponential. So you'll use some sort of little trick. There's a 3-step process for making an inverse to make its inverse. So find its domain and range, then find its inverse. And then I'll ask you the follow-up question, of course, which will be what is the inverse's domain and range? But that's for later. Sketch and make the inverse. Okay, we need to get going here. So hopefully you started by saying x equals 5 to the 4y, and then you rewrote it. Log base 5 of x is equal to 4y, and then you take 1/4 of both sides, and you have 1/4 log base 5 of x is your reversed, solved, and therefore the inverse of the original function. Raise your hand if you got the same thing. Okay, good. Now, if you were to sketch the original, do you get that that was exponential growth and therefore something like that? Exactly what that slope was, we don't know, and that's okay. So that's just a rough sketch of what it would look like. And then do you get its inverse? Would be something like that. And it's at a reflection across that line right there, y equals x. Does that make sense? Okay. Then, backing up a notch, if I go back to this, what's its domain? That's going left, right with the x's. Yes, sir? All reals. Good. And its range. 0 to infinity. So if I just asked for the domain of this new function right here, you would not have to sketch it. You would take the range of the original and therefore 0 to infinity. Can't be 0. Question on that one? That one came from the range of this original one, because the domain of the new function would be the range of the original. All right. Have I done a U-substitution with you yet?
No.
All right. We should probably practice that. E to the 2x minus 5e to the x is equal to 6. Nope, we're not going back. Sorry. You can ask me later if you want to. Low on time and heavy, a little bit oversupplied on problems. I got lots of practice problems I can do with you still. Okay. Did you say let e to the x equal u? Raise your hand if you figured that out. Okay, good. That was a u substitution. This is just saying, please substitute in a u for me so it'll be so much easier. U squared minus 5u, subtracting the 6 from both sides gives me this. I factor it into u minus 6, u minus 1. Where did I just make a mistake? U plus 1, very good. And then when it's all said and done, u must equal 6 and u must equal negative 1. Why did I get the problem wrong then? Yes, because now we have to turn it back. And it was originally e to the x, so now we put it back to e to the x equals 6. E to the x equals negative 1. Why am I again wrong? Why can't I stop right there? Yes. What are you doing right now? Yes, you're doing a rewrite. That one doesn't work because you're not allowed to have a negative in that spot. That's the argument. All right. What's the answer?
0.
Good. Why? You won the argument? You get nothing. Good. All right. What's the answer? What do you think, Z? It doesn't work. Okay. You're not allowed to have a 1 on the base. You're exactly right. No solution. How about this? Could you tell me 2 ways you could do it? Tell me all way you could do it to start with. rewrite. 5 to the x equals 1/5. And then you just think about it. You take 5 and you put it to the what, and you get 1/5. And the answer would be -1. Okay. Option B. How else could I have done it? Make it into? Exactly. And then these are the same, and therefore this whole thing becomes -1. Nice. Okay. You can take logs on both sides. Can you take logs off of both sides? All right. Have we solved one? And I'm losing track because I've had several classes today already. Have we solved one like that in this hour yet? Okay. Try that one. It's a lot like problem number 1 that's on the wall over there. You remember when you had the 5 hard problems and you walked around in groups and solved those things? It's like that one. There's going to be a lot of algebra in the end of this one. Yes, sir.
So for us to cancel logs off of both sides of that
Same base. Yes, there has to just be one. As simple as that. So if there's 2 logs, you'd have to condense them. But you can do that. Right? We've learned how to condense. So in this one, option A, you can put a log on both sides. Then, if you're doing a log on both sides, you can pick log base 5 or you can pick log base 7. Option B is just rewrite it. You can rewrite it from either side. You could pick, I'm going to rewrite it with that being my base. Log base 5 of blah, blah, blah. See if you can do it. There's many ways to solve this one. But the trick in the end, it'll come down to getting the x's all on one side. And if you can factor it, you should. This would be the hardest one. In fact, I'd predict that less than a third of you would probably be able to pull it off. So don't be surprised if you struggle a little bit. But you can do it. We've done ones just like it. Okay, so here we go. First step. I'm going to choose to do the log base 5 thing on both sides. And I know a lot of you are going to be like, but that's not how I did it. It's going to come out the same. So the x plus 2 then just drops down in front. You could think of it that way. Or I could think of this as equaling, the answer is the exponent. X plus 2 equals log base 5 of 7 to the x. And then either way, if I did a log base 7 or I did a log base 5 on both sides, you got to drop one of the exponents down. So this exponent has to come down here. Okay? There. Now, I've got x's that are on opposite sides. I got to get them both together. I'm going to subtract x from both sides, and that will get the x's all to one side. Now I'm going to go 2 equals. X gets factored out. If you can factor it, you should. And then I'm going to divide both sides by that, and I'll have x alone. I know, that was intense. But it really boils down to, if you multiply it all out, you'll have something like this. X plus 3 times, let's say, log base 2 of 7 equals, let's say, 4. No, wait, I have to have an x over there, so 4x. This type of problem confuses a lot of people. Because why? Because mainly it's got x's on both sides. This is another one that's not the same one I just did. This is another one. Do you get how here I would start by multiplying this out? And then I would have x's on both sides. Then I would move all the x's to one side. So I'm going to show you this one quick. X log base 2, 7 plus 3 log base 2, 7 equals 4x. Then I got x's on both sides, here and here. I'm going to choose to get this one over there. So that'll become minus x log base 2, 7, sorry. Then I could factor the x out, and I'd have 4 minus log base 2 of 7 equals 3 log base 2 of 7. And I would have to divide both sides then, and again I got x alone. Divide by 4 minus log base 2, 7. All right, the test is tomorrow. One last thought. I would encourage you to consider watching the log high school videos that are there. There's this big thing in the Chapter 8 folder called Log High School. And it's also got a practice test in there that you can take. So those are some options that you could do to study for tonight. Have a great day.